Very similar to lesson 8.A, solving linear quadratic systems of equations. This lesson we're going to work with quadratic systems. So again, it depends how the two equations fall on the graph as to what and how many solutions you're going to have. In same scenarios, none, one, or two. If the two graphs do not intersect at all, then since your solution is going to be where they intersect, you're not going to have any solutions. It's possible they just meet up at one single point. That does take a pretty special scenario to happen. It won't happen that often, but that is a possibility. And then what occurs most often are where the two graphs overlap and you come up with two solutions. So more than likely that's how your answers will fall, but you do have the option of getting no solutions or one solution. Okay, again, we're going to stay with the same concepts that you learned in Algebra 1, solving linear systems. You had the substitution, the elimination, and the graphing method. I chose to take this example through substitution because I have one variable solved for itself, x squared. So it doesn't have to just be x. It can be an x squared. And I'm going to take what x squared is equivalent to, and I'm going to substitute it into the other equation. So all of this is going right there. So I get the negative 3. I have the 2 times, but instead of having x squared, I'm going to replace that or substitute it with 9y squared plus 36, and I have a minus y. You'll also notice in this particular problem I have opted to solve for y first instead of x. It doesn't really make a bit of difference. So when I distribute here, I'm going to get 18y squared plus 72 minus y. So I have a quadratic equation. I would like to set it equal to 0 so I can solve it. I have 18y squared plus, minus y. And I'm going to bring this 72 over and make that 75. I'm going to add the 3 from this side to join up with the 72 there. That's where the 75 is going to come from. I can choose to work with trying to factor this out. I can do a lot of things, but just to be safe, I'm going to review with you how to do quadratic formula. So A is 18, B is -1, and C is 75. So these are some pretty large numbers that we're working with. Instead of x equals, that's going to be y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so y equals 1 because it's negative, and then b is negative, so those two negatives make a positive, plus or minus the square root of b squared. Well, -1 squared is going to be 1, minus 4 times 18 times 75 all over 2 times 18. And when you work this out, what you end up with is a negative number under the radical, which is not possible. So therefore, we would say that this guy has no solutions. So I told you it doesn't happen much, but it can happen. If you can't come up with a y value, then there's not going to be a point that exists. So this would be a case of no solutions. All right, so let's move on to the second example. I've chosen this one to do with elimination because I have the pair already lined up. However, they're both positive, so I need to make one negative. I'm going to make this one negative. So everything gets negated. If it was positive, it becomes negative. If it was negative, it becomes positive. And then we add down. So a negative y and a positive y give me 0. We have a negative 5 with a positive 2 is negative 3, and plus 3x squared. So this is a quadratic equation. I'm actually going to use the square root method on this one. Added the 3 over, getting the squared term by itself. And when you square root each side, please remember that when you put the square root in the problem, which is what I did, you have to put a plus or a minus with it. So y is equal to plus or minus 1. That means when I go to plug in it, I got to plug it in once with the positive and once with the negative. So when I do it with the positive, my y value is 2 plus 2 is 4. And when I do it with the negative, because I'm squaring it, I'm also going to get 4, which gives me 1 with a positive 4 and negative 1 with a positive 4. So this guy's going to have two solutions to it. Okay, which is, what I told you is going to happen most often. And I can check these by plugging the 1 and the 4 back in. Like if I said 5 minus 1 squared, that would give me 4. 2 times 1 squared is 2 plus 2 gives me 4. So these equations, that one checks. If I did the same thing with the negative 1, that would check also. So you can always check your answers. All right, now as far as using your graphing calculator is concerned, one thing you need to remember is that when you go to solve your equations for y, so that you can put it into the y equals of the graphing calculator, y squared problems are actually comprised of a plus or a minus square root of x. So when you put them in your calculator, you have to put the first equation is going to take up two spots, one for the positive, one for the negative, and then the second equation is going to take up two spots, once for the positive, once for the negative. So, because it actually graphs one equation, then it graphs the other equation, because this guy isn't a function. He doesn't pass the vertical line test, and your calculator can only graph functions. All right, so this is supposed to be joined up here. So when you look at this, you want to kind of get an idea of where your points of intersection are. This one's going to have 2, so that when you go through the process of second trace 5, you kind of know where to click around. And so we want to get to this point right here, we're going to have to use y1, which is the positive square root of x plus 6, positive 2 positive square root of x plus 6, and we're going to have to use y4, which is the positive 8 square root of x minus 4. So those are the two that got intersected, and you can see that in the upper corner. If you're not sure, you're just going to use your arrows, the up and down arrows, to go in between the different functions. And you'll see the flasher guy flashing on the right function. And so you move it around until you can find that one. You'll hit enter on the first curve, enter for the second curve. You'll need to hit enter on the guess screen, and then you'll want to make sure that when you go to give your final answer, it's the answer you acquire off the intersection screen, okay, which is going to be that answer right there. And then you would repeat the whole process to find the second point of intersection. So you would arrow around until you see the flasher guide down here. So that's how you can use the graphing calculator to help with that. All right, so if you look at this one, you can do elimination. I said substitution. It really doesn't matter on this one. I'm actually going to change my mind here, and I'm going to change this method to elimination just because I've got those two x squareds lined up. The only problem with them is they're both positive, so I'm going to need to go through and change all the signs. All right, so that's going to give me a 3y. These guys are going to cross out, and that's going to give me an 18. So I know my y value is 6. I take that 6, I plug it into the top equation. You can do either one. So when I put 6 in here, I'm going to get negative x squared equals negative 4 because I'm going to subtract 6 and subtract 6. So x squared equals positive 4, so x equals, and again, remember, I'm putting the square root into the problem, so I need to remember a plus or a minus 2. So this guy's going to have two answers. He's going to have 2 with 6, and he's going to have negative 2 with 6. Okay, so that's how you can do quadratic systems. Not much different from um, the linear quadratic systems. You just got to be careful, especially using that calculator.